Principles of electric motors that you couldn't quite grasp in school for a year will now be explained in just 2 minutes. Start with 2 magnets. You'll notice that opposite poles attract, while like poles repel. Now, take one of the magnets and drill a hole in the middle, then place it on a stick. Take another magnet and bring it close to the first one. The magnet on the stick will rotate to align with the opposite pole. If we change the pole of the second magnet, the magnet on the stick will rotate again. But this method is quite labor-intensive. So, we take a metal bolt, wrap a few coils of wire around it, and then connect both ends of the wire to the positive and negative terminals of a battery. As the current flows through the wire, it forces the magnetic domains in the bolt to align, turning the bolt into an electromagnet. Now the bolt has a positive and negative pole, just like a magnet, and can attract or repel other magnets. If we flip the battery, the direction of the current changes, and the poles on the bolt will switch as well. However, it's easier to swap the wires than flip the battery every time. Next, we fix the bolt onto the stick and place magnets with opposite poles on each side to strengthen the effect. At this point, while the bolt will keep rotating, we still need to constantly swap the wires, so we came up with a better idea. We replaced the small magnets with larger rectangular magnets and use a metal commutator instead of the bolt, adding a split to it. With a commutator in place, we no longer need to keep switching the wires. We then add a pair of brushes to each side of the commutator and connect them to wires. Now, when we turn on the power, the current flows through the armature, turning it into an electromagnet that begins to rotate. When the rotating commutator's contact with the brushes changes, the current flows in the opposite direction, flipping the polarity of the electromagnet. This eliminates the hassle of constantly swapping wires. To make the motor spin faster, we can add more armature circuits. The more armature circuits there are, the faster the motor spins. In theory, the more armature loops, the higher the speed of rotation. This rotational force is what we call torque. Next, we replace the metal commutator with multiple coiled commutators, increasing the magnetic force. Now, we have a complete DC motor. This type of motor can power devices like electric toothbrushes, fans, and even electric vehicles. Basically, anything that requires rotational motion.